Hi again. So let's take a deep dive into regressor scores. When interpreting scores, it is important to understand the problem you are trying to predict. A score could be considered very good when trying to predict human behavior. For example, why is your child so messy? But the same score when trying to determine if someone should have heart surgery could be very bad. For each score, there is a baseline score and then the score produced by the model. The baseline is the simplest way to reach a prediction. For a regression analysis, the baseline would be the average number in the column you want to predict. For example, if you wanted to predict the price a house will sell for, the baseline would use your historical data and calculate the average price of houses that are sold. Then the results of your more complicated model would be compared to the simple baseline, and you would know if it's any better. Besides using the baseline score, your model's value can also be compared to the current process in place, if there is one. That process might be a real estate agent taking last year's house sales and adding 10%. If there's no current process at all, then perhaps using the model is a good idea. In this demonstration, I'll examine the scores produced in a regression analysis. With my regression tool selected, I'll expand the advanced score section. Let's look at the error score. In data science, this score is referred to as a symmetric mean absolute percentage error, or SMAPE. You can see this score in the badge at the top right of the page, and it's also the large score located in the configure pane. In the advanced score section, you can compare this score to a baseline score. Baseline score is the yellow bar, and the model score is purple. Regression models will receive an error score, which indicates your model's measure of error. The error is how far off you were in your prediction. For example, if the true price of a house was $120,000 and your model predicted it would sell for $110,000, you would have an error of negative $10,000. The error score provided is a percentage that ranges from 0 to 200%. The closer the score is to 0, the lower the potential for errors. If you have a model with an error score of 0, you should be very suspicious. You may have a column in your model that should be excluded because it contains post information. Post information is information that you wouldn't have when you're ready to use your model to make a prediction. If Symon builds a model using post information, your error score will be close to 0 and your predictions will be extremely inaccurate. A good or poor score is highly subjective and dependent on the problem you're trying to solve. In this case, the house price analysis attained a score of 13%. It's much better than the baseline score of 42%. This can be considered a good score. Also, if there was no other process in place to predict the price a house would sell for, then this model would be good to use. Let's examine the R-squared score. This score indicates a goodness of fit for the model. It measures the strength of the relationship between the model and the target column on a scale of 0 to 100%. In this case, the target column is the price. With a score of 88%, the relationship between the model and price is quite strong, indicating a good fit. In other words, the model does a good job of explaining the changes in house prices. The mean squared error provides the average of a set of squared errors in your model. The lower the mean squared error, the better the prediction. Remember the example where a house sold for $120,000. If the model predicted it would sell for $110,000, there would be an error of negative $10,000. Well, the mean squared error finds all of the errors, squares them, and then adds them up to find the average. Squaring the errors gives more penalty to when the model is really wrong. If you hover over the yellow baseline score, you can see the number is bigger than the model score. There are more digits in the baseline score if you look closely. So again, the model is better than the baseline. Mean absolute error makes all of the errors positive, so they don't cancel each other out. Again, the lower the error, the better the prediction. So, the error of negative $10,000 would become positive $10,000. Then the positive errors are added up and the average is calculated. With this score, big errors or differences between the actual and predicted values are not penalized any more than smaller errors, as in the mean squared error score. Again, you can see the number is bigger in the baseline score than the model score, so the model is better than the baseline. And that's it. Now you know quite a bit about regression scores.